just like the Copernican revolution, replaced the geocentric and anthropocentric Ptolemaic cosmology with an objective model of the motion of the cosmos, so we must replace observer-based relativity and the observer-created reality of quantum theory with an objective theory of what is, exists and what causes the motions and events that we observe. We must ask questions that have long been ignored. Relative to what, in the cosmos, that light move at velocity c? Is light actually a wave? Of what? Relative to what in the cosmos, that matter have inertia? Does empty space itself have physical qualities or not? Is space a void, or is it some sort of substance? This will demonstrate that today's four-force atomism is not an objective theory of physical reality at all, but only a default model based upon subjectivistic measurements and concepts. Demonstrating that only an ethereal theory of space and a wave model of light are consistent with all the known evidence. In the Dark Ages, Aristotelian philosophy and Christianity were married, but with the discovery of Aristotle's works of natural philosophy, churchmen perceived a threat to their beliefs, and the marriage became strained. Thomas of Aquin attempted to reconcile the partners, but could not prevent the inevitable divorce. In 1277, just 3 years after Thomas's death, the Bishop of Paris issued a condemnation of many Aristotelian, Thomist works. This divorce was accompanied by a religious backlash against Aristotle and all natural philosophy. William of Ockham tried to completely free theology from cosmic philosophy. To do so, he limited philosophy to the mere description of experience, and against physical causation and evolution, he stressed the omnipotence of God, and the radical dependence of all created things upon God, for both their existence and interaction. For Ockham, there was a created world, but there were no God-independent, physical entities or processes. Therefore, to study nature was to study God's free acts. Ockham therefore insisted that man should only describe his actual experiences, he should only note the regular sequences of observed events, not hypothesize about any God-independent natural causes or mechanisms. For Ockham, experience-based propositions, not cosmic entities and processes, were the proper objects of knowledge. The purpose of Ockham's razor was clear: to eliminate all composite theories of physical entities and causation, in favor of the simplest cause of all experienced phenomena, God. René Descartes went one step further towards subjectivism. He sought to confine knowledge to what was given to us by God, and about which we could be certain, the clear and distinct ideas presented to the senses. The apparent cosmos, he supposed, could be a hallucination produced in his mind by some demon. Descartes was persuaded to believe in the existence of the physical cosmos, because it appeared to exist, and he believed that God would not so deceive him, if it were not so. Bishop Berkeley completed the move toward idealism and subjectivism, and away from cosmic philosophy. In the post-Copernican world, he feared that as more and more phenomena were explained by natural causes, acting in a physical cosmos, faith in the God of Christianity would gradually give way to natural philosophy. He saw all philosophical explanation as a slippery slope leading to atheism, so he tried to replace cosmic philosophy with a purely descriptive approach to knowledge that had no need for the cosmos, or for physical causation. He argued that, since we humans know only our own conscious experiences, and have no direct knowledge of any material cosmos, we must not assume that it exists. He argued that we should accept the simpler theory, that all reality is purely spiritual, that our experiences are not caused by any physical world, but are a virtual reality, provided directly to our disembodied minds by God. Rings a bell? Echoing Ockham, Berkeley argued that, since God alone makes one experience follow another, philosophy should merely note these regularities, and not pretend to explain things by corporeal causes. Berkeley's idealistic, subjectivistic, anthropocentric argument was essentially a religious program of limiting the scope of natural philosophy to a mere modeling of a viewer's sensations and measurements in the viewer's frame of reference. Like Einstein's special theory of relativity, the Aristotelian, Ptolemaic model of the cosmos was naively based upon the viewer's mere description of his sensations and measurements. The Earth's surface observer felt no movement as he watched and measured the movements of the stars and planets. He created a model of their motion in his frame of reference, the spherical Earth on which he stood. The model worked to account for the motions of the heavenly bodies and to predict future positions. It was refined to great accuracy over the centuries. There was only two problems: the strange, unnatural zigzag movement of the planets in their orbits about the Earth, and the requirement for several different kinds of ad hoc fixes, deferents, equants, epicycles, resulting in great mathematical complexity. Copernicus, a monk, physician, and a philosopher, did not believe that God's creation could be so unnatural and complicated. He revived Aristarchus' idea that the sun, not the Earth, was stationary, and that Earth was just another one of the planets circling the sun. His opponents raised arguments, some of which were eerily similar to those used today by defenders of Einstein's relativity and quantum theory. They asserted that, if the Earth was moving so rapidly, there should be some kind of wind. The motion should be evident to their senses and instruments, an idea that eventually produced the Michelson-Morley experiments and their misinterpretation. The opponents of Copernicus argued that, if the Earth was rotating, everything on its surface should be flung off into space. Both arguments, we know now, were made from ignorance of the nature of gravity and of space. They also argued that Copernicus' model was inaccurate, even though its calculations were much simpler than those of the Ptolemaic model. This was because Copernicus had presumed that the planets moved in perfect circles around the Sun, an error that was not corrected until Kepler discovered that the orbits were actually elliptical. The Copernican revolution demonstrates that the difference between an observer-based system of description and a theory of cosmic structure and motion is anything but trivial. Even though the Ptolemaic cosmology worked, as today's models work, mankind had to abandon it completely in order to gain any understanding of space, motion, and gravity. The Copernican revolution was not a scientific revolution, it was not an improved model of the facts of observation, it wasn't even more accurate. It was a revolution in the choice of the frame of reference to be used for the description of motion. It was an instance of mankind using our theory-creating ability in order to reach beyond the evidence of our senses and instruments, to create a theory of what existed and caused our experiences and measurements. This was a philosophical, not a scientific revolution. Einstein's relativity and quantum theory were a regression to the anthropocentric epistemology of the Ptolemaic cosmology. Special relativity, SR, is a model of the observer sensations and measurements, without any reference to any objective cosmos, as if the only reality is the observer conscious experience. SR asserts that light moves at c, relative to each and every human observer, regardless of his state of motion. Can there possibly be a more subjectivist concept? Wouldn't any objective cosmology relate the motion of light to some aspect of the cosmos, perhaps its large masses, galaxies, stars, and planets? Wouldn't any objective cosmology try to explain why light might appear to move at c, as measured by every observer? General relativity, GR, does at least include the effect of mass on the observer space and time measurements, but it remains an anthropocentric model. It is not a model of an objective cosmos that changes through time. It's a static, four-dimensional model composed of the only thing that different observers can agree upon, their measured space and time intervals between observed events. It models a space and time matrix that coordinates every observer experiences. Quantum theory likewise models the observer experiences of the interactions of light and matter. It neither posits any underlying objective reality, nor attempts to model that reality. Its only reality is the observer's conscious experiences. Ironically, today's physicists do not recognize the true nature and limitations of their own models. They falsely assume that these are objectivistic models of an objective physical cosmos, and they mistakenly use them, and their measurement concepts, flying photons, invariant C, space-time, etc., to theorize about the nature and causes of cosmic phenomena. It doesn't work. Like the Ptolemaic cosmology, their model makes no sense of the phenomena, and they are continually forced to resort to ad hoc hypotheses and fixes, renormalization, wave-particle duality, sums over histories, many universes, streams, dark matter, dark energy, etc. Now, when you attempt to accelerate a mass that lies on a frictionless surface, what resists the change in velocity? When you try to change the axis of a spinning mass, what causes the resistance you feel? And the force that pushes the mass perpendicular to the direction you are pushing it? Why does a pendulum continue to swim in the same direction, relative to the sun and stars even, as the Earth rotates under it? Is the frame of reference that accounts for these phenomena truly relative? Can one choose any frame at random to describe these phenomena? Or is there a single, specific frame that is uniquely causative? Does the causative frame have anything to do with any human observer? Can one truly produce gravity by a mere choice of frame, as Einstein claimed, or does mass alone produce gravity? Does light really travel at sea, relative to every observer, or relative to the cosmos? Why? When we are to move beyond the mere modeling of the observer experiences, and instead create a model of the cosmos, we encounter the question of space. We must choose between two fundamental hypotheses: either empty space is nothing, or it is something, either not A, or A. There is no middle ground, there are no other possibilities. We must choose between these two mutually exclusive hypotheses, atomism and etherism. Atomism, space is nothing, a void, featureless extension, a mere container. Space has no physical qualities, and neither causes nor interacts with any phenomenon. Gravity, electromagnetism, and all other cosmic phenomena are the products of the interactions of various particles flying through a void. Etherism, space has physical qualities, and is therefore some kind of substance. It is the physical substrate of the cosmos and all its phenomena. Gravity and electromagnetism are just different kinds of stresses or motions of this substance. The known particles are themselves persistent patterns of motion of space. This issue has been successfully evaded for centuries. Physicists and cosmologists are forced to populate empty space with more and more unseen particles and energies. Fallacious reasoning is rampant. It is regularly argued that, because one particular ether theory has been proven false, therefore any ether theory is false. Since 1905, when Albert Einstein's papers on special relativity and the light quantum were interpreted as implying that there was no ether, theoretical physicists have simply defaulted to atomism and ignored the evidence for the physicality of empty space. So when physicists attempt to theorize about the nature of cosmic reality, they simply ignore the unreality and the contradictions that follow, all the paradoxes of relativity and quantum theory. For instance, Newton's theory of light was atomistic and space was absolute. It consisted of particles flying through an absolute space, that even though acted upon matter to resist its acceleration, was not affected by matter at all, implying an action with no reaction. Huygens, and later Thomas Young demonstrated that light was a wave instead, and Faraday and Maxwell achieved tremendous successes by modeling electromagnetic fields and waves as alterations in an electromagnetic ether. The question then arose, is the electromagnetic ether identical to Newton's absolute space? Does light move as a wave with velocity c in Newton's space? Michelson and Morley tested this hypothesis using a light wave interferometer on the Earth's surface. They did not detect the ether wind or fringe shift that should have been caused by the Earth's revolving motion through Newton's space. Lorentz, Fitzgerald, and Stokes offered theories to explain the null result, without abandoning an ether wave theory. Lorentz and Fitzgerald proposed the existence of a length contraction and frequency reduction caused by motion in the ether. Einstein appropriated the Lorentz-Fitzgerald ether model and equations, and applied them only to co-moving observers' frames, eliminating the ethereal and electromagnetic middle term, and ignoring the fact that the existence of an electromagnetic ether was necessary to produce these quantitative relationships. He admitted that this cosmic, mass-influenced frame constituted an ether, yet he failed to admit that this objectivistic ether concept contradicted his own subjectivistic principle of relativity that modeled the effects of gravity and motion upon the observer rulers and clocks, and therefore upon his constructed space and time intervals. Yet Einstein stated, quote, recapitulating, we may say that according to the general theory of relativity, space is endowed with physical qualities. In this sense, therefore, there exists an ether. According to the general theory of relativity, space without an ether is unthinkable, for in such space there, not only would be no propagation of light, but also no possibility of existence, for standards of space and time, nor therefore any space-time intervals in the physical sense. Close quote. Notice, however, that Einstein used the term space ambiguously, since according to the axioms of special relativity, and his subjectivistic epistemology, space was nothing more than a number of rulers and clocks counted by the observer. He also stated, quote, but this ether may not be thought of as endowed with the quality characteristic of ponderable media, as consisting of parts which may be tracked through time. The idea of motion may not be applied to it. Close quote. In other words, space is a substance, but we must never think of it as a substance, or theorize about it. Why the prohibition? Why did both Newton and Einstein affirm that space was a substance, and then try to ignore and evade the implications? Shouldn't humans always follow the evidence, wherever it leads, and seek the causes of all physical phenomena? The cause of this particular inhibition is obvious, if one studies the debate about space throughout history. The nature and role of space is intimately connected to our ideas about God and our conceptions. An ethereal space fills many of the roles that have been assigned to God and to spiritual, mystical entities. It is the ground of all being, and sustainer of all phenomena. It would exist, even if there were no mass or motion. It is potentially eternal. The conflict between ether theory and theism is clear. An ethereal cosmos that exists eternally, and self-evolves to produce particles, atoms, life, and consciousness, necessarily leads to a form of atheism. It provides an actually working theory of the ultimate nature of all being,